Hi, this is Florian for televisions.com. Here you'll see a video I recorded while aboard the Home Theater Cruise 2009, where many experts gave lectures on a range of useful topics.
If you know, in theaters, silver screens are coming back. Does everybody know what a silver screen is? It's a highly reflective, high-gain screen, and incidentally, the properties of the screen are such, I guess they're coated with aluminum now instead of silver. But when you touch them, the aluminum oxidizes. So just like a frying pan, an aluminum frying pan, you know, when you boil water and it gets all mucky and whatever, and you have to take a steel wool to clean it up. Well, there isn't any taking steel wool to the screen to clean the oxide off. And basically, silver screen was a technology that's over 100 years old, or 100 years old, thereabouts, approximately. And the silver screen gave us a lot of gain, so that the dim lamps of the projector of the day would give a bright enough picture so that an entire audience could see it, but it hot-spotted something fierce. And the real silver screens actually color shifted something fierce. They would actually, they weren't neutral in their ability to reflect light. That most of them went in the direction of plus blue, so that the information that came back off the screen was far more blue than the information that actually hit the screen. The problem with that is if you moved your head, you would see a differential color, and the color would constantly change. And we've improved screen technologies since then. Obviously, they've come a long way. And a flat spectral response is also a part of getting decent uniformity off the screen. As much as you can have hot spots, when you move around the screen, if there's a differential gain in color, you'll see a color change. And I expect all of you have looked at screens and moved your head and seen color changes in the screen. Well, that comes from the fact that there's a differential gain, and depending on where you look, you see different amounts of red, green, and blue based on that differential gain. Anyway, so now we come to 3D, and we come to the polarized versions of 3D. And the first thing that happens is that silver screens are the only, well, there's silver screens and other technologies that emulate silver screens, but you basically have to maintain the polarity of the polarization. One eye is vertically polarized, the other eye is horizontally polarized, and you wear glasses where you only see the appropriate image for the particular eye. And in theaters, that is being considered one of the best ways of doing 3D presentations, because the glasses are inexpensive and they're easy to wash and reuse if they decide to take that approach. Where any of the other methods of doing 3D, as an example, Dolby Laboratories has a system where they comb filter the color spectrum. If this, you know, from left to right represents the entire color spectrum, what they do is they comb filter the spectrum. They put one color in one eye and they put another color in the other, another set of filtered colors. Now, those glasses are expensive. They're about $50 a piece, and they would allow you to show 3D on any screen. Now, all of these systems, whether it's a polarized system, circularly polarized, vertically horizontally polarized, or the color filter systems that are being suggested to make 3D inexpensive for theaters, all involve having to filter the video. Do any of you remember composite video? When we talked about Yves Ferrugia, he would filter the diagonals because the color spectrum would go into the diagonals, and if he filtered the diagonals, he got rid of the cross color. Well, we have the same situation now optically happening, that when you have horizontal and vertical polarized images, you actually have to filter the diagonals, because the diagonals are in between horizontal and vertical. So in order to get a good picture, you have to filter detail. In the color system that Dolby's proposing, you have to filter color detail so that there isn't cross color between one or the other. So all of those systems for doing 3D in theaters involve compromises, severe compromises. Whether it's the screen that has to maintain the polarity, which happens to be a high gain screen that color shifts, and is hard to maintain or easy to maintain with some of the newer screens that are coming out. They still have hot spotting that we don't necessarily have to have with current technology. They involve, most important to me, all those systems involve having to filter the content. The only system that allows you to have full detail is shuttered glasses. So that it's first one eye, then the other eye, and it's this sort of thing. And those, you can have full 1080p or full resolution images. I don't care whether they're film or whatever. There's no filtering required, there's no loss, there's no color loss, there's no detail loss. That right now appears to be the only practical system for coming forward in 3D. So all that you'll read about a plethora of systems in the Widescreen Review article, and most of them aren't valid as far as I'm concerned because they require us to take major steps backwards in what we're currently capable of doing. Now, in the home, I want a 100% compatible 2D, 3D system. I want the best possible screen that can get me the best possible image from the projector. And when I go to 3D, I don't want to throw any of that away. You know, I want to be able to use the same screen. The reality is all I want to do is be able to put on the glasses and suddenly I have 3D off the same system. No changes to the system whatsoever. The only difference is when I put up 3D information, I have to put the glasses on to see 3D. Now that to me is the most compatible system, and a shuttered glass approach so far is the only approach I've seen in the industry that will allow full compatibility between 2D and 3D. So when I'm working in 3D, when I talk to people, and I've been spending a lot of time in the last 6 months doing that, I'm saying shuttered glass approach is the only approach that works in a home theater application.
Is there a perceived decrease in light output with the shutters?
The answer to that is there is attenuation in the shuttered glasses that they don't fully open. So that you lose light through the glasses, there's no question of that. And that's where this new 6,000 lumen light, because all I have to do is turn it up. You know, okay, what did we lose? Okay, so when we go into the 3D position, we automatically boost the light.
Is the shutter mechanism the transition lens kind of thing, or is it a mechanical shutter?
Oh, I'm sorry about that.
Is it a mechanical shutter, or is it a lens?
Well, mechanical shutter. It's actually the glasses that I use are LCDs.
Okay.
Or yeah, they're LCD glasses, and basically I can make them opaque or transmissive by controlling the voltage on the glasses. And what we do is we put an infrared synchronizer back at the projector, and we hit the screen with an infrared synchronization signal, and then there is a pickup on the glasses that synchronizes left eye, right eye. That's basically how it works. So there's a battery in the glasses, and you're going to have to periodically replace the battery in the glasses in order to make that work, or charge them up. When you're not using them, to charge them up. Glasses, current price on them is around $50, the same as the Dolby glasses. All right, the question is how many people are working on 3D sources?
Delivery formats or?
Well, no, I meant studios, TV.
How many people are actually producing programs?
Right.
Last year I think it was 2 films. This year I think it's about 18 or 19 films.
In 2010, 17 3D films were out.
I'd say 2010, 17.
Now, you talk about looking at Blu-ray. Will that mean a new generation of Blu-ray player, or is it just a different way of encoding data onto Blu-ray? Or
There are proposed systems right now that are perfectly functional on all level 2 players.